Hi and welcome to this on maths prediction for the AQA Maths GCSE Paper 2 Foundation Tier, November 2020. Enjoy! Hi and welcome to this Paper 2 prediction from onmaths.com. If you haven't done the Paper 1, then you won't know that you can go and this link here, and it will take you straight through to onmaths.com where you can try this paper out completely for free, and you can even sign up for free. It will save your scores and all that stuff. You can do that before you even watch this video, or what some people do is they like just to watch the video, understand how to do the questions, and then test themselves afterwards. So what is the prediction? Well, prediction basically is our estimation of what comes up every single time with this exam board, what hasn't come up in ages and is long overdue to come up, and it's basically a guess. And it's an educated guess, but it is a guess, and that's why I say in every video, don't just do this and rely on it 100%. There will be a lot of topics that come up in this paper, but there also will be new topics that don't come up. So make sure you do all your revision, whether that's with onmaths.com or mathseffect.co.uk or a different website or a different revision guide or whatever it is. Make sure you do the work first. Otherwise, let's get started.
You will need to be familiar with the names of three-dimensional shapes. So the one we have here is a triangular based prism. So a prism is a shape that you can cut anywhere along one of the axes, so anywhere along here, and it would look exactly the same. It would look like a triangle. The first bit of this, triangular based, is just the name of the shape at the end, the name of the shape at the end of the prism. So you can have a hexagonal based prism or anything like that. It says write down the number of faces. So the faces we can see, well, the face we can see here is a triangle, so that's one. Then we've got one along here, which is a rectangle. So we've got two that we can see, but there is also going to be a third one round here, which is also going to be a rectangle, a fourth one at the bottom, which is going to be a rectangle, and then a fifth one round the back, which is going to be a triangle, just like number one. So in total there are 5 faces. Try and remember what a face is. A face is something you can lay your hand down flat on. An edge is something that you can run your finger along, so that's an edge there. And vertices or vertex is something that if you put your finger on, it would be pointy. So there are going to be 6 vertices. For this question, we need to understand the difference between multiples and factors. Multiples are just a numbers times table. So the multiples of 5 will be 5, 10, 15, 20, etc, etc. Now every number in the 5 times table ends in 0 or 5. So looking at the list of numbers we've got here, there's only one that ends in a 5 or a 0, which is 10. So 10 is a multiple of 5. Now factors go the other way. A factor of a number means that the number, so 24, is in another numbers times table. So 24, and the easiest way to find the factors of 24 is you start off with 1 and 24, because 1 times 24 is 24. Then you go 2 times, 12, 3 times 8, 4 times, and you think how many 4s? 6. 5 times, well that doesn't work. 6 times we've already got. So those 8 numbers are the factors of 24. Then I look at the list, well, already there's a 24 there. Is there any other ones I could have written? I don't see any other ones, so 24 is my answer there. 2 prime numbers. Now prime numbers mean they only have 2 factors, 1 and themselves. Okay, that's a prime number. If there's any more factors, it's not a prime number. So let's go through the list. 10 is in the 5 times table, which we identified in question A, so that's not a prime number. 24, well, we've listed out 6 other factors of 24, so that's not in it. 18 is 3 times 6, so that's not going to be it. 17, I don't think of any times tables that 17 is in, so I'm going to say 17 is a prime number, which it is. And 19, well, I can't think of any times tables 19 is in, so I think that's a prime number. Let's go through the rest to make sure. So 16 is 2 and 8, so that's not a prime number. And any even number apart from 2 is not going to be a prime number. 2 is the only even prime number. 27 looks like it might be, but actually 3 times 9 is 27, so it's definitely not. And 28 is another even number. So it looks like we found the 2 prime numbers. So to find a coordinate, it's really simple. There's only one mistake really that people make. The first thing to do is find out what the x coordinate is. So the x coordinate is 2. And so the first coordinate is 2. Then find out what the y coordinate is. So the y coordinate is -3. Now some people think of this as starting in the middle and going along the corridor to the 2 and then down the stairs, or up the stairs. This one it's down the stairs to -3. Now it's really common for students to get these muddled up, so just remember we always do the x, so the horizontal, we go across first and then the y, which means we go up or down. When you're rounding numbers to significant figures, first of all write out the number. And with significant figures you want to draw a line after the second number. So the 6 is the first number, the 3 is the second number. Now unlike decimal places, you're not looking at counting from the decimal point, you're counting from the start of the number, and we'll have a look at an exception to that on question B. Then we look at this number. Now this number and the 2 are doomed. They're gone. But they're not quite done yet. That blue one has to make a decision. If that number is a 5 or more, that 3 will go up by 1. If it's less than 5, that 3 will stay the same. Now because it's less than 5, that 3 will stay the same. But have a think about it. If 6,312 people visited or were at a football match and someone said, oh, can you tell me roughly how many that was? If you said 63, that doesn't make any kind of sense. So the mistake that I've made, and the mistake most people make with this question, is they forget that the 1 and the 2 don't disappear. They turn to 0. So the answer is 6,300. Now on question B, this is an exception that we've got to remember with significant figures. You don't start counting until you hit a number that's not a 0. So the first number is 5 and the second one is 2. So the line will go here. Then let's have a look at our decider number where it's 1 again, so it's less than 5. So we're going to have 0.052. Now I could put 0, 0 in here, but this time the numbers aren't actually affecting anything. Was before, the 2 zeros there were holding that 6 to 6,000 and the 3 to 300, so they were really important. The zeros here aren't actually changing the number at all, so we don't need to have them. So the answer is 0.052. So for the first question, when you're adding letters together, the answer will be a number and then that letter. So we've got 1, 2, 3, 4, 5. So it's going to be 5b. The most common wrong answer is b to the power of 5. Now that's wrong because that only happens when you times them together, when you multiply them together. So it's going to be 5b for the first one. Next one is 10 lots of f and we're taking away 3 lots of the f. Well, how many f have we got left over? Well, 10 lots of it and take away 3 lots of it means we've got 7 lots of it left. When you're simplifying one like this, in algebra we just don't use the time sign, so this is quite a nice easy question, 10ab. Now the last one is like terms, so we've got 5x here and we're adding 5x, and we've got a 3y here and we're taking away a y. So when you add the 5x to the 5x, you get 10x. And when you've got 3y and you're taking away y, which is short for 1y, so we've got 3 y's, taking away 1y, we're left with 2y. Now you can't simplify that any further because they are not like terms. You can times them, but you can't add or subtract them. To answer this question, first of all, we need to know what the gradient is. So what you do is you pick 2 points that you know the coordinates of, which is that one and that one I'm going to pick. Works with any of them. And we work out how much up and how much across it's gone. Well, it's gone 1 up, but I'm going to do this in pence. So I'm going to say it's gone 100 pence up, and it's gone 10 miles across. So to work out the gradient, we're going to do the change in y, so how much it's gone up, over how much it's gone across. Now, some students have that the wrong way around because coordinates work the other way around. You go along the corridor and up the stairs. With gradients, how far you go up or down over how much you've gone right. So that's going to be 10. Now, it says give an interpretation, so we haven't finished answering the question. What does that mean? Well, it means for every 1 mile that we've gone, it's going to cost 10 pence. Now remember, I converted this into pence, so instead of in pounds, it's going to be pence. So the gradient is the cost per mile. And I'm going to put in brackets 10p. Now, it could be that just writing the cost per mile for this question would give you the mark, but if you actually wrote the gradient as well, then you definitely get the mark, and sometimes it will ask you for the gradient and then ask you to interpret it. So you'll need a calculator for this question. The different calculators do things slightly different, but by far the most common calculator, and if you haven't got one, I would recommend them, are the Casio calculators. Mine has a shiny solar panel on the top, but you don't need that. The average battery life lasts way longer than you'll ever need the calculator. So the first button I would press, and there's different ways of doing this question, is the button to get the fraction, which on the Casios looks like this. And that will make a fraction appear on your calculator. Now, some of the older ones, the fraction looks a bit weird. It involves like a symbol like this. And actually on the new ones it can, but you need to change the settings if it does that. It should open up, it should look something like this, like a box and then another box, and there should be a cursor blinking in this box. Okay, so we want to fill in this top box first, since it's already flashing. So 76.8 plus 81.9. Okay, and so to shift downwards on the Casio calculators, there's a sort of cursor, like a cursor stick, a direction button thing. It's the big blue button beneath the screen on most of the calculators, and you just push the down to go to the denominator of the fraction. And then we need to fill in this bit here, so 0.19. And then to get the squared button, it's on like that. So you just press that, and it looks exactly as it does in the question on the screen, so you know you've got it right. So you press the equals, and my one comes up with 4396.121884. Now, it might be tempting to try and round that, but it says it wants all the figures, so just put them all in. Now, if your calculator is set to a mode which it's going to show even more numbers, then normally six digits after the decimal point is more than enough. They won't require you to go to 100 or 200 decimal places. On this question, that's actually an exact amount. Okay, so write down correct to 2 significant figures. Now, to do 2 significant figures, we start counting at the start of the number. So I'm going to do a red line where you need to start counting. And you just count 1, 2 numbers. So the blue line is where I've stopped counting. Now, all of these numbers here are going to be reset to 0. they're going to go away. Well, not quite. Let's come to that later. Now, this number here, the 9, is what we call a decider number. Now, that number is going to go. That 9 is gone. Okay? But before it goes, we need to see whether that is 5 or more or 4 or less. If it's 5 or more, it pushes that 3 up to a 4. So the answer will be 4, 4, and then you'd think, oh, okay, that's it, rounded, and you'd write that in the answer column. But when I said they disappear, they don't quite disappear. All the numbers above the green line that I've just drawn reset to 0. They turn to 0. Now, if you think about it, if I don't know what would have a decimal place, but if you have a number 4,396.121884 written down, and someone says, "Can you tell me roughly how much that is?" Then if you say the answer of 44, that's not roughly 44. It's nowhere near 44. So the 9 and the 6 will turn to 0. And actually the other numbers do too. But these numbers here are not changing the number at all. These 2 zeros here will make that 4,400 instead of just 44. The other numbers after decimal point, we might as well get rid of them. So the answer is 4,400, okay, because we don't need to show these numbers. Now, the reason students make this mistake is they're so used to decimal places. Now, decimal places, you always remove them because they're always after the decimal point. But with significant figures, they need to turn to zeros. When you're asked to do a plan or a front or side elevation, it's important to remember that the diagram you're going to be drawing must be absolutely square on. So there's not going to be any 3D lines at all. It's just going to be 2D shapes like rectangles. Sometimes you have triangles. Occasionally you might get a circle or a semicircle. So let's have a think. What does plan mean? Plan means view from the top. So what of this shape are we going to see from the top? Well, we're definitely going to see this one. But we'll also see this one as well. Now, we've got to work out what the sizes of them are going to be. Well, the top one's easy. It's just 7 centimetres by 6 centimetres. Now, I'm not going to be able to draw this accurately because I don't have a ruler. But we can almost get it right. We can get it kind of right. And if I label it, that's going to be 7 centimetres, and that should be 6 centimetres. And in your exam, just make sure you actually measure them because they are said to you in here, and it does say accurately construct. So you want to make sure that it's done 7 centimetres and 6 centimetres. Now, the difficulty is going to be the last bit. Well, we know it's going to be 6 across because it's the same as this one here. But what's the width going to be? What's this one going to be here? Well, if this one here is 7 and this one here is 9, what's left over? Well, there's 2 centimetres left over. So it's going to be 2 centimetres in width. Ooh. Let's use this one, right. So it's going to be 2 centimetres in width. So 2 centimetres there. And this one obviously is going to be 6 centimetres, the same as the right hand one. Now this line we have in the middle, this line here, is really important because that shows that there's a join, that there's something happening there. So you need to construct, you need to show that, especially if there's a change in elevation, just show it with a line on the diagram. Okay, so this is quite a tricky question because it mixes fractions and ratios together, but we've got to be comfortable with that. So I'd first of all just show the information so that I can get my head around it. So we've got Denver, who as a fraction has 3/19 of the food, and so that leaves how much? Well, we've got a calculator, so we could just do 1 take away 3/19 on the calculator, but we know that that's going to be 16/19. So we can kind of ignore Denver now because we used Denver's amount, or fraction of the food, to work out Engels and Fido's combined. So that's how much food they'll get, but they're sharing it in the ratio of 5 to 2. So in total, the amount of parts they have is 5 plus 2, which is 7. So there's 7 parts altogether. Okay, and each part, so one part is going to be worth, well, as a fraction, it's 16 over 19 divided by 7. So 16 over 19 on the calculator divided by 7, which gives us 16 over 133. So that's the fraction of each part. Now it says, show what is Fido's share. So we're looking for Fido's share. Now Fido gets 2 lots of that. So looking for Fido, he gets 2 lots of that fraction. So I'm going to times that by 2 on the calculator, which is 32 over 133. Now it does say show your answer as a percentage rounded to the nearest percent. So to work between fractions and percentages, I just need to times by 100. So what I can do is just times that by 100. I'll do it on the calculator, times by 100, and press S to D if it comes up as a fraction. And it says 24.060 blah blah blah. So to the nearest percent, Fido gets 24%. Okay, so this question's about an adult and 2 children. So we've got David Smith and 2 children. So there's 1 adult and 2 children. But the prices shown are not quite right because there's a discount. There's a 5th off adult price and 30% off the child price. So let's work out the adult price first. So a 5th off. Well, first of all, let's work out a 5th of £70. So to work out a 5th, you can just divide 70 by 5. Now I know that 10 5s are 50 and 4 5s are 20, so that's going to be 14. So that's going to be £14 he gets off. So therefore the price will be the £70 take away the £14. So 70 take away 10 is 60, take away 4 is 56. So he's going to pay £56 himself. Let's do the child price. Okay, so it's 30% off the child price. So we want to do 30% of £37. Okay, let's do the equals down here to give us some room. Well, I know that 10% is going to be £3.70, and then I need to times that by 3. Okay, so I could just times it by 3. Let's have a think. I could do 370. I could do it in pence, and then just times that by 3. So 370, and then I can just do times 3. So I can do a little grid. And if this is on the calculator, then obviously you just type it into the calculator. And obviously that's going to be 0, so we don't need that one. So it's 900. That's 21 with a 0. So 900 plus 21, 210 even. 0, 1, and then 11. So that's going to be £11.10. And so we want to work out the price. So it's going to be £37, take away £11.10. So if you take away 10 it's 27, take away 1 is 26, take away 10 is £25.90. Now that's for 1 child, so that's 1 child. So if I want 2 children, I want to do £25.90 times 2. Now I know 25 times 2 is 50, 90 times 2 is £1.80, so that's going to be £51.80. Okay, I'll move down a bit, and let's do the total. So the total is going to be the adult price, which is this one here, plus the 2 children price, which is that one there. So I want to do 56 plus £51.80. And again, if you've got a calculator, you can just type it in, but let's do the column method. £1.80, and then people like putting the zeros in. So that's going to be 0, 8, 7, 10. So that's going to be £107.80. So it's £107.80. Finished. Okay, so this question is about Venn diagrams, and it says there's 37 students in total, and it says 10 only like the red car, so 10 only like the red car, 9 only like the blue car, and 8 said they liked the red car and the blue car, so 8 in the middle there, and those are the values for A, B and C. Now it says how many students did not like the red or the blue car. So if we add all those together, we get 27, but there's 37 students in total. So if we take them away, we get the answer of 10. So, and we can actually show that on a Venn diagram on the outside, like that. So let's fill in my answers, 10, 8 and 9. Okay, it says, a student's chosen at random to discuss their views. What's the probability the student liked the red car? Well, let's have a look. There's 10 people who only like the red car, and there's 8 people who liked the red car and the blue car. So in total, that's 18 people who like the red car. Just 8 of them happen to like the blue one as well. And in total, there's 37 students. So it would be 18 over 37. Okay, so the numbers in this question seem a bit daunting, but the process is always the same with this type of question in ratios. The first thing you've got to realise is, are you given a total amount or are you given an amount of food or amount of drink? It says in total they spend that amount, so it's a total amount. So step 1 is to work out how many parts you have altogether. So for food it's 39. And for drink it's 4. And this will be a calculator question, so why not use the calculator even though we can do it in our head. 43 parts. So we've got 43 parts. The next stage of this is to work out what one part is worth. So one part is worth how much? Well, you get the amount and you divide it by the number of parts. You're splitting the amount of money between 43 parts. So 11911 divided by 43. And I get £277. So each one part is worth £277. Now let's read the question. Find how much money is spent on drink. Well, drink is this one here. And the order which they are in the question, food, drink, is the order which the ratios are. So food, then drink here. So there are 4 parts. So we're just going to write drink. So if each one part's worth 277, we're just going to do 4 lots of that. And I might as well do it in the calculator. Times by 4. And that's going to be 1108. So 1108. Instead of going straight to percentages for this question, I would first of all get it as a fraction. So it says there's 15 students who are female and 31 altogether. So the fraction is going to be 15 over 31. And to simply convert between fractions and percentages, all you need to do is times by 100. And percent means per 100, so it's always going to be times by 100, and that'll always get you a percentage. So I'm going to get my calculator out. Now I can write that as a fraction, or I could do 15 divided by 31. It gives you the same answer. So 15 over 31 times by 100. And it gives me a fraction, so I'm going to press S to D. And it's 48.3870, blah, blah, blah. And it says give it to the nearest percent. So that's a 3, so it's not going to move that 8 up to a 9. So it's just 48%. Okay, so we've got a scatter graph question, and the first question asks us just to plot the information from the table into the scatter graph. So we've got ice cream sales at the top and temperature at the bottom, which is not kind of the same way around as on the graph, so we've just got to be careful. So the ice cream sales are 46, which is here on the scale, and the temperature is 31, which is here on the scale. And just check that you're looking at the scale correctly. So we're looking about, let's have a look, about here. Okay, next one, ice cream sales 40, which is here on the scale, and temperature 34, which is here. So we've just got to be careful, and it's about there. So those are the two plots that we want to take. Next question says, on another day had an average temperature of 45 degrees. Use the scatter graph to estimate the sales of the day. Now, you need to get used to just drawing a line of best fit to any scatter graph that you come across. You will have to do it, okay? So just do it. Just, even if it doesn't ask you to, just draw a line of best fit. Now, a line of best fit is just a line that follows all the data like that. You should have roughly the same amount of data top and bottom, but it doesn't matter if it's not perfect, okay? So let's have a look. So we've got average temperature of 45 degrees. So we're going to draw a line up from 45 degrees, which is about there. And we're going to draw, oh, the line didn't come up. So let's draw that line there. It's refusing to come up for some reason. Let's try another one. There we go. Let's try another line. Okay, let's do it the old-fashioned way. Okay, and then we draw a line across from where it's the line of best fit. Now, to me, that looks like about 55. But if you had the same question and you came up with a different answer of 54 or 58, it still can be correct because you might have drawn a slightly different line of best fit. Okay, so don't worry if you sit down next to someone, do the same question and get a slightly different answer. Just draw the lines, straight lines, unlike mine, onto your diagram to show the examiner that you worked it out. So we've got 55 sales we're predicting. Now, what do we notice about this? Well, look at where all the data is. All the data is here, and yet we're estimating outside the range of the data. Okay, it's called extrapolation where you do that. So the problem with that, if you imagine we do a graph of height against age, so we have age at the bottom and height up the side, then when you're very young, you grow quite quickly. And if someone extrapolated your data and said, oh, okay, well, that growth is going to continue, when you're 80 years old, you're going to be 20 foot high. Well, that doesn't make much sense. It's because we're quite confident with down here because we've got data for that, but we're not very confident with this bit here. We don't know whether the trend continues. Now with ice cream sales, if it's ridiculously hot, no one's going to leave their house. They're all going to be sitting inside with their air conditioning or sitting in their car with their air conditioning. So we know it probably won't continue. So if you just say that the estimate is outside the range of the data, and if you want to really impress the examiner, then you can use the word extrapolated. It's been extrapolated. Okay, factorise means put it into brackets. So looking at the first one, there's a t I can divide out of both of them, so I put t on the outside of the bracket, but there's no number because 7 and 5 don't have anything that goes into both of them. So I think, what do I times t by to get to 7t squared? Well, it's going to be 7t. And what do I times t by to get to 5t? Well, it's just going to be 5. And you can check your answer by expanding the bracket, check it makes 7t squared plus 5t, which it does. Next one, w is only in the first term, so I can't divide out the w, but there's a number I can divide out of both of those. Now, I could pick 2, but actually 4 is a better number because it says factorise fully, which means I need to take out or divide out the 4 rather than just the 2. So 4 on the outside. What do I times 4 by to get to 12w, or 3w? And what do I times 4 by to get to minus 8? It's going to be minus 2. And again, I can expand that to check it. Right, the last one, there's a number and a letter. So I'm thinking the number of 16 and 24 would be 8, and the letter would be A. Okay, so there's two things that we're dividing out this time. So I'm going to have 8A on the outside. So I figure out, what do I times 8 by to get to 24? Well, that's 3. And what do I times A by to get to A squared? Well, that's going to be A. What do I times 8 by to get to 16? 2. And what do I times 2 by to get to 16A? So it's just going to leave it because the A is on the outside of the bracket. So A to A times 2 is 16A, so I don't need an A there. First thing we need to realise with this question is, which transformation is it? Well, you have to go through the 4 transformations. The first one I think of is, has it rotated? Has it spun around? No, it hasn't. Second one, is there a mirror image of it? No, they both look the same, so it's not been reflected. Has it grown or shrunk at all? No, so it's not an enlargement. So that leaves transformation. Translation. Translation. Now, translation just means we've moved it, and that's perfect because we have just moved A to B. Now, the second thing to realise is we are starting at shape A and we're going to shape B. Now, with translations, to describe them, pick the same point on both shapes. I always pick the top left if it's available. Then, what we want to do is work out how far left or right I have to go from A to get in line with B. And I do this with jumps. And the reason we do this with jumps is I never get the wrong answer when I do jumps. So, 1, 2. I need to go 2 left. So, 2 left. And let's have a think. How much up do we have to go? So, 1 jump, 2, 3, 4. So, 4 up. Now, the way of showing translations is by using vectors, and it sounds fancy, but it's just putting this information here between a bracket. The number at the top of the bracket is how far right it's gone, and the number at the bottom is how far up it's gone. Well, let's do the number at the bottom first. So translation by, there's different words you could use there, and the number at the bottom, well, it's gone 4 up. So it's just a 4 there. Now, here's a problem. This is how far right it's gone, but it's gone 2 left. Well, we just simply put minus 2 right. Now, be careful. Don't ever put a fraction line between the minus 2 and 4. It's not a fraction, okay? So don't ever put the fraction line in. These questions are just based on a few rules of indices. The first rule says that if you've got 2 powers with the same base, which these two do because they're both A, you add the powers. Now, if you think about it, A squared is A times A to the power of 6 is A times A times A times A times A times A. So in total, we're timesing A by itself 8 times. So it's A to the power of 8. The next rule says if you've got a power inside the bracket and outside the bracket, you times them together. So it's m to the power of 3 times 6, which is m to the power of 18. Now this last one's a little bit more complicated, and I'm going to write it out so I've got a bit of a larger one to play with. Okay, first thing I focus on is the number. Now 55 over 11, so I know that 55 divided by 11 is going to be 5. 55 divided by 11, that's all we've got to do. And the reason we can do that is there's only one term at the top and one term at the bottom. A term is defined by, whether there's a plus or a minus, and there's no pluses or minuses here. Okay, so the next one, we've got the r's that we want to divide. So we've got r at the top and an r at the bottom. Now this r at the top is technically r to the power of 1. Now when we do r to the power of 1 divided by r to the power of 8, which I'm going to write out down here so I can show you, you take away the powers. So when you times them, you add the powers. When you divide, you take away the powers. So that's r to the power of minus 7. Okay, now we're left with the s's. And it's the same thing with the s's. This time we're doing s to the power of 15 divided by s to the power of 8. So it's going to be s to the power of 15 take away 8, which is 7. So my answer would be 5 r to the power of minus 7 s to the power of 7. Okay, to convert from standard form, you just write the number down, and this here, the power, will tell you where to go. So if the power is positive, then you go to the right. If it's negative, then you jump to the left. Now since it's negative, we're going to jump to the left, and it's minus 6, so we're going to jump 6 spaces. So 1, 2, 3, 4, 5, and 6. So the decimal point will now be here, and you fill in all of the jumps with zeros. So one of the jumps is used by the 8, but all the other ones we fill in with zeros. And whenever you've got just a decimal point, you need to have something before it, so we put a 0 before it. So the answer will be 0.00000084. That would be the answer. So let's just count. There's 5 zeros and 5 zeros. Okay, to convert to standard form, you write out the number, and you try and put a decimal place in to make the number between 1 and 10, but not including 10. So if I put it in here, that would be 72, so that would not be right. So I need to put it in here. Then you count how many times you had to move the decimal point to get it there. So the decimal point started at the end of the number, and we had to move it 1, 2, 3, 4, 5, 6. Okay, so the rule is that the number has to be between 1 and 10, which this one is. Now, if you had a big number, then the power of 10 will be positive. Now here we did have a big number, so it's going to be positive 6. On the previous one, we had a small number, 0.000084. I don't know if I said the amount of noughts that were there, and you can see that the power in the question was negative. So negative power of 10 is really small number, positive power of 10, really big number. This does turn up on the calculator paper as well. So if it does, you can actually just type in question A into your calculator and just write down the number it gives you. Now some calculators are smart and do things in standard form, so you might need to do it this method anyway. The triangle we need to remember for this question is density equals mass over volume. Now you could have kind of worked it out with the question, because it says grams, which is mass, per centimeters cubed, which is volume. So per means over, so it would be mass over volume. So we need to work out the mass. Well, at the moment we have the density, so we've got that, but we haven't got the volume. So the first thing I need to do is work out the volume of the prism. So to work out the volume of any prism, it's the cross-sectional area times the length. And some people call the length something else, but the length is basically how 3D the prism is. So the length is this one here, and the cross-sectional area is the area of this triangle here. So it's the area of the triangle. We've got the base, which is 4, and the height, which is 9. So it's half times base times height, and then we're going to times it by the length, which is 10. So what have we got? The base, which is 4, so it's half times 4 times the height, which is 9, times 10. Now, the reason I know the height is 9 is that it hits the base at right angles, and that's really important. The base and the height must be at right angles. And don't forget to halve it. Now, what I can do here is something quite sneaky. What I can do is I do half times the 4 to get 2, and that saves me timesing some big numbers together just to halve it. So 2 times 9, which is 18, times 10, which is going to be 180, or you can just type it into the calculator if it's on the calculator paper. Okay, so that is in centimetres cubed, because every unit is in centimetres, and make sure you check that. So the volume is 180, so to work out the mass, if I cover up the mass in the diagram, so I cover that up, it says to work out the mass I do density times volume. So it gives me the density in the question, which is 5.5, and I'm going to times that by 180. So if I have a calculator, I can just type that in. Otherwise I could do 5 times 180, well I can do 10 times 180, which is 1,800, then halve it, which is going to be 900, and then half times 180, which is 90. So that's 990. So the answer is 990 grams. Alright, so we're asked to draw a frequency polygon, and the only error you're going to make with this type of question is figuring out what a frequency polygon is. Now, a frequency polygon is where you put little crosses at the points, and the points lie at the group's midpoint. So we've got our first group 0 to 10, so the midpoint would be 5. Next one is 10 to 20, so that's going to be 15. Then 25, then 35, then 45. So the first one's going to be at 5, and it's going to be 6 high. It's going to be like that. Next one's 15, 22. So 22 would be about there. 25, 59, so 59 would be right up here. 25. 35, 15. A little bit lower than that, but that's fine. 45, 4. Now we're only halfway done, and my points aren't exact because the screen I'm using isn't the most precise, but it's good enough. We're only halfway done because what we need to do is join these up with straight lines, so no curves needed. And when you join them up with straight lines, do not ever join up the last 2 points. You're not actually trying to make a polygon, okay? So don't ever, when you join them up, whatever, right? Don't ever draw this line here, okay? That's not a good thing to do, so make sure you don't do that. Okay, and that's it. So midpoints, crosses, and then join them up with straight lines if you're asked for a frequency polygon. Alright, so it says that the town council is saying that over a quarter of the stores get over 30 customers. So we're going to see whether that's right. So over 30 customers would be these two groups here, so 30 to 40 and 40 to 50. So that is 19 altogether. So that's 19 out of, and let's add all the rest up, so 6 plus 22 plus 59 plus 15 plus 4, out of 106. It didn't say it in the question. So it's 19 out of 106, which as a decimal, 19 over 106 be 0.179 to 3 decimal places. So what I would say in the exam is no, because that is 17% or 17.9%. So it's less than 25%. And just write a sentence saying that yes, it's close, but it's not quite at 25%, because even rounding up to the nearest percentage, it's 18%, which is 7% lower than 25%. So just make sure you write all of the numbers in an answer that answers the question. So this question looks quite complicated at first, but actually there are two very simple-ish ways of doing it. We've got 2 decagons, and so that means they are 10-sided. And you can just count the sides if you want, but if it says it's a decagon, I trust it, it's a decagon. Now what we can do is we could work out the interior angles of the decagons. Well, they'll be the same, so I can just work out one and then double it, and then take that away from 360 to work out A, And that's absolutely fine, that'll get you the right answer. A quicker way maybe, and especially on the non-calculator paper, but it works on both papers, is to draw a line up here and realise that you've got two exterior angles there. And the beauty of exterior angles for polygons is they always add up to 360. So to work out the exterior angle, always write down what you're working out. All you need to do is 360 divided by the number of sides the regular polygon has, and they have to be regular, otherwise you can't just divide them because we're assuming they're the same. So that's 36. So if that one's 36 degrees there, and that one's 36 degrees there, then all you need to do is 36 times 2. Well, 6 times 2 is 12, 30 times 2 is 6, so that's going to be 72. So let's show the examiner that. 36 times 2 equals 72 degrees. Okay, so there's quite a few different ways you can do this question. I'm going to find out length CB, and then I'm going to, from that, find out length CE. So this question asks us for length CE. Now CE is the length that's shown at the bottom here. This is CE here. Okay, so that's the one we're trying to find. Now I'm going to first of all find out what CB is. Now what I'm going to do is just label this X, and I realise that it needs to be trigonometry because this is a rectangle, that's a right angle. So I'll need to use trigonometry for it. So we've got opposite and we've got the hypotenuse. So we're going to use sine, so SOH. So it's going to be sine 68 equals 27 over x. And I'm going to times both sides by x and divide both sides by sine 68. So that gives me x equals 27 over sine 68. And so if I do that on the calculator, 27 over sine 68, and that gives me 29.1204. And I just do a few more decimal places than usual because it's not an answer and you should never round your working out. If it's asking for one decimal place, I think 4 decimal places should be enough, but I'm going to try and keep it into the calculator if I can. So the next thing I need to do is work out CE. Now I'll need this angle here, which actually I can just take away 68 from 90 because it's a rectangle, the whole thing will be 90 degrees. So I'm just doing 90 take away 68, which is 22. So that's 22 degrees. Now I'm looking for this one, so CE. I'm going to call CE Y. And I've got, so what have I got? I've got the adjacent here. So this is now the adjacent. And I've got the hypotenuse because this is opposite the right angle. So this time I'm going to be using cos. So it's CAH. So cos 22 equals equals my 29.1204 blah 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 over y. So again, I'm going to times both sides by y and divide both sides by cos 22. So y equals 29.1204 blah 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 over cos 22. Now I kept that in my calculator, so I can just press divided by cos 22. Press equals, and it's 31.4074 blah blah blah, and it says it wants the answer to one decimal place, so it's going to be 31.4. Now if I lost you a little bit because I went quite quickly through trigonometry, this is a kind of question you do when you're quite happy with trigonometry. There's loads and loads of videos on the site that go through right from the basics of trigonometry. If you want to do these questions completely within the trigonometry triangle, then that's absolutely fine, you'll get the same answer. The easiest way to answer this question on the calculator paper is to think in terms of multipliers. Now multipliers are a nice easy decimal you times something by to do whatever the question's asking you to do, so either increasing it by a percentage or decreasing it by a percentage. So if we ignore the second part of the question, just focus on this bit, 11% off. We always start off with 100%, always, and 11% off would have taken away 11% from that. So that's going to leave us with 89%. Now 89% is not a multiplier yet. All you need to do is divide it by 100 to make it a decimal. So in your calculator or in your head, divide it by 100 and you get 0.89. And that's a multiplier because all we need to do is put any number in here, we times it by 0.89, and it gives us what the new number is with 11% taken off. But the difference with this question is we're not working this way, we're working this way. So if you have a look at the question, it says the sale price is 917, work out the price of the TV before the sale. So the end price is 917. So instead of timesing it by 0.89, when we're working the other way, we divide it by 0.89. Now I show it this way round because I like to have it in the middle, but we've got to do 917 divided by 0.89. Don't do 0.89 divided by 917, otherwise it won't make sense. So on the calculator, 917 divided by 0.89 and press equals. You might get a fraction, just press S to D. And we get 1030 pounds 34. So I've rounded that to the nearest penny because the next one along, it's 337, so the 7 pushes that 3 up to a 4. And so that's going to be 1030, so 1030 pounds 34. Let's see if that makes sense. Well, it kind of makes sense that it's gone down a little bit to 917 pounds. So the actual thing makes sense. We'd expect the price before the sale to be higher than the price on the sale. Something you can do to check that it works is you can then times the answer by 0.89, and there we go, we get 917, so it completely makes sense. Okay, with this question, the first thing to realise is that we have two similar triangles here. So we've got the smaller triangle here, and we've got the bigger triangle here. And they are mathematically similar because this angle is going to be the same as this angle because they're parallel lines, those are corresponding angles. This angle is going to be the same as this angle for the same reason, and this is a shared angle. So they're two triangles with exactly the same angles, therefore they have to be mathematically similar. And mathematically similar means all the angles are the same, but we've just multiplied all the length by something to get to the new triangle. So, important first step of this is to draw out the two triangles. Okay, and I'm just going to sketch them out roughly. So a small one, and we've got the big one. And then copy the length. So this is going to be 23, this is going to be 9, this is going to be 36 at the bottom here, and this one's going to be 60. Okay, now ask for the value of CE, which is this bottom length here. That's the bit we're trying to find. But I'm going to ignore that, and I'm going to work out what AC is. The reason for that is if I know AC, I can take away from 60 to work out CE, because I know the total distance is 60. Okay, to do that I need to work out what the scale factor is. And the scale factor, all you need is a length on both of the triangles, which is corresponding, which means it's the same length, but on the two different triangles. And to do that, we do the big length. I say the same, it's not going to be the same length, but the same position on both triangles. So big length over small length. Okay, so the two I'm going to pick is obviously the bottom two. And we're going to find out what we times 9 by to get to 36. So 36 over 9. And that's obviously going to be 4. Okay, because 4 times 9 is 36. Okay, so we know we times that by 4, so the scale factor is 4. Now, if we go from big to small, we times it by 4. But here we're going from, so if we go from small to big, we times by 4. But here we're going from big to small. So instead of times by 4, we're going to divide it by 4, because it's going to get smaller, isn't it? So we're going to do 60 divided by 4, and I should really write down what I'm doing. I'm doing AC, and that's going to be 15. So we know that it's going to be 15 here for this bit, okay? But the total is 60, and we're looking for what's left over. So we're going to do CE equals the total 60, take away the bit we know that we don't want, and that's going to be 45. So the answer is 45. Okay, so we've got an athlete and 2 hurdles, and if he jumps the first one, the probability of him jumping the second one will change. So it's a conditional question, and we're asked what's the probability he will hit one hurdle. Now, one hurdle does not mean 2 hurdles. One hurdle means exactly one hurdle. So you've got to be careful with the question. Okay, so we start here, and if he jumps the first one, then we're looking at him hitting the second one, because he has to hit a hurdle. So we're looking at him hitting the second one. If, however, he hits the first one, he can't hit the second one, otherwise we'll end up hitting 2 hurdles, and it says it will hit 1 hurdle. So he has to jump the second one. So he's either going to hit the first one or the second one. Okay, what we need to do next is work out the probabilities he will jump the first one then hit the second one. So we just get the 2 fractions and times them together. So that would be 4 over 70. No need to cancel at this point. Okay, and let's work out the probability you hit the first one and then jump the second one. So that's 3 over 7 times 10 over 13. So that's going to be 30, and then I could do this in the calculator or just do it in my head, over 91. Okay, now we're either going to end up here where he's hit the second one, or here where he's hit the first one. The word or in probability means add. So he's either going to hit the second one, or, which in probability is add, hit the first one. So on the calculator, because this is a calculator question, so it'd be 4 over 70 plus 30 over 91. So that's going to be 176 over 455, and let the calculator do the hard work there. Now, if it's a non-calculator question, generally speaking, the denominators of the fraction are a little bit simpler, and they tend to do those on the independent ones because they can manipulate the denominators a little bit more. Okay, I'm just going to write this out to make it a bit bigger. Now we're asked to make A the subject, which means we want A equals. So I'm going to put my lines down. Now the first thing I need to do is get rid of that square root, because if you look, the right hand side is all trapped in that square root. So what I'm going to do is square both sides. So we've got t squared equals, and when I square the square root, it just gets rid of the square root. Okay, next I need to get rid of that 3, so I'm going to take away 3 from both sides. So we've got t squared minus 3 equals 10a. Then I'm going to get rid of that 10. Now that's a times 10 there, so I need to divide both sides by 10. Now I could divide the t squared by 10 and the 3 by 10, or I can just write it as a fraction, which is a lot easier. So just put the whole thing over 10. So therefore a equals t squared minus 3 over 10. Now it's really important that if the letters are capitals, we keep them as capitals. If they're lowercase, we keep them as lowercase. It does matter what case the letters are, so if it's uppercase or lowercase.
Well, I hope you found that video useful. If you did, please click like. If you want to see more from us, including the other 2 papers, please click subscribe. We've got loads and loads of stuff on the website on maths.com, which you can go to here, which is completely free. But if you feel you're quite far behind in the maths, or you're not happy with the grades you're getting on onmaths.com or other mock papers you have, you can try out our premium service, which is mathseffect.co.uk. With mathseffect.co.uk, it's a small monthly fee, And you can do an annual subscription, but if you only want to do it up until November, which makes sense, you can just pay per month. And what it does is it has the whole of the Maths GCSE as a journey, and you go through each topic, mastering it one topic at a time. A lot of the students I talk to say, I really don't know where to start. Like, I keep doing Pythagoras and trigonometry over and over again, and I don't really know what else I don't know. This is a service which just covers everything. It makes sure you master and you are an expert in every topic in maths. So it's worth checking out. Loads of people have joined already, and if you haven't joined, go to the website mathseffect.co.uk or click the link in the description. That will take you straight there and you can check it out. Otherwise, thank you very much. If you want to leave a comment down below of anything you want us to cover, because we're desperate to help anyone who's being caught up in this terrible situation, which is not ideal for anyone, but equally, like, we all understand why it's happened. But if I was having to resit or having to sit for the first time in November, I would feel exactly the same as you are probably feeling. So if you want to leave any comments down below, and we might release some videos just discussing options that you have open, or whatever it might be. Otherwise, thank you very much, and I'll see you in the next video.